Alright, we are starting chapter 2, and the focus of chapter 2 will be solving equations. At the end, linear equations, which means one variable, nothing bigger than an exponent of 1. And at the very end of chapter 2, we'll also do inequalities, where we replace the equal sign with a less than, greater than, less than or equal, greater than or equal. We'll use the exact same methods that we do to solve the equations all the way through chapter 2, with just one extra little twist for the how to deal with the inequalities. Okay, so we want to recall the differences between an expression and an equation. An expression, there's no equal sign. And an equation, of course, has an equal sign. That's the difference between an expression and an equation. So some algebraic examples of each here. An expression might look like y minus 5 or z plus 13. An equation example might be y minus 5 equals 18, or z plus 13 equals negative 15. So the difference there being that you've got an expression with no equal sign, and then over here for the equation, the expression is set equal to another expression. Could just be a single number, that's fine too. So in expressions, the value of the variable can still be anything. So in an expression, the value of the variable can be anything. We don't know what y is. We don't know what z is here. We could be given a value for y and z, plug it in, and evaluate what that expression would equal if y equaled a certain number or z equaled a certain number. But at this point, y or z could be anything. So it's a true variable. It could change. But once you get over to the setup of an equation, the equal sign, okay, that little piece we put in right there, the equal sign narrows down what the variable can be. Or what the variable can equal. So in an equation, the equal sign begins to give us a clue about what the variable can be. It narrows it down. It restricts it, so to speak. You don't just have y minus 5. You've got a value and you're going to subtract 5 from it. But you have a value that after you've subtracted 5, you get 18. Okay? You no longer just have a variable that you're going to add 13 to. You have a value, an unknown right now, that once you add 13 to it, it will equal negative 15. So it's giving you some clues now, giving you some restrictions even of what those variables can be equal to. So we're going to start with just the basic look of what a one variable linear equation looks like. This chapter is written with the end of Math 60 in mind, which is chapter 4, linear equations, where we're going to focus on graphing lines, how do you recognize those equations, solving, finding pairs of points, that kind of thing. So they want to introduce this concept of it being linear right now, but we're going to keep it at one variable. When we get to chapter 4, the number on the other side of the equal sign will be replaced with a y value. Okay, we will keep it open-ended because in a line there's a whole bunch of pairs of points that create a line that get connected together. So there has to be an x and y value for each of those. We'll get to that in chapter 4. So for now, what the book is meaning by a linear equation is truly just a one variable linear equation, and it has the basic look of ax plus b equals c, and we'll talk about what that means here. Okay, so to be a basic one variable linear equation, like this example on number 2, okay, this is a linear equation. It has an x, or a single variable, okay. It has an equal sign, so this is kind of the checklist for how do you determine if it's a linear equation or not. So the first thing, check for it has just a single variable. The second thing you check for is it has an equal sign. The third thing you check for is that A, B, and C are real numbers. So no imaginaries, okay? But you could have fractions, decimals, negatives, okay? So these numbers right in front here, A, B, and C, let's highlight those just a little bit here. A, B, and C, those numbers, those will be numbers when you're looking at variable. In this case, we've got our A value, let's see, our C value is 20, there's our C. Our B value is actually negative 15. You want to think of this as plus a negative. So the B value here is negative 15 in this case. The A value is going to be 1 because we don't see it there, but when you just have a plain old variable, you say x, you're saying what you have is 1x, okay? We talk like I have a dog at home. You don't say I have a one dog at home. We just leave off that one. It's the singular, so we just say I have a dog at home. I have an x here in the equation, x minus 15. There's 1x. The fourth thing you want to check for, and just to make sure before you can decide if it's a one variable linear equation or not, is that the exponent of the variable is 1. It can't be any higher than 1, can't be any different than 1, can't be a variable or an exponent of 0 or an exponent, a negative exponent. It has to be just an exponent of 1. Okay. The last thing you're looking to make sure that is not happening is that x is free of other operations happening to it. For example, no radicals, no absolute value. Okay, you don't want x being inside any of those. As soon as that happens, you're not talking about a linear relationship. There's not a regular pattern of growth there, because the absolute value makes everything positive, so it doesn't allow x to travel, doesn't allow the results to travel up and down the number line. It keeps everything in the positive. The square root of x starts to delve into a different type of pattern, a different type of relationship, because things will then grow and shrink exponentially. That's why we can't have, we want linear growth on this, just a basic pattern. So, and I know that's a lot of information to take in all about this, but what I want you to see is what we're really looking for here, because all these other things create different types of equations, and we want to be focused in Math 60 on this one variable linear equation. So it has an x, has an equal sign. A, B, and C are real numbers, which means it could, those real numbers could be radicals, or could be negatives, could be decimals, could be fractions. All those are real numbers. Could even be 0. 0 is a real number. We make sure the exponent of the variable is just 1. So this is when you don't see a exponent, it is just 1, x to the first. And then x is free from being trapped in other operations. Okay, it's not caged anywhere. There's no x in a radical, no x in absolute value. So there's the book definition. We're going to travel now on the next video to the bottom of the page and look at 3 different examples, and they're all not linear equations. So we'll kind of use this checklist to determine what's involved that makes them not a linear equation. Okay, we'll see at the bottom of the page.